I'm Anil Kumar, and here is a test question for you on analyzing critical points. So let me write down test. I'd like you to pause the video, copy the question, answer, and then look into my suggestion. The question is, consider the function f of x equals to x minus 3 times cube root of x. Find all critical numbers for f of x and determine whether each corresponds to a local maximum or a local minimum or neither. So that is the question for you. Here is my suggestion. Let's begin by finding the derivative, right? So we know the function f of x is equals to x minus 3 cube root. I could write as x to the power of 1 over 3, right? We can use power rule now. So let's find the derivative. Derivative will be 1 minus 3 times 1 over 3 x to the power of 1 over 3 minus 1, which is minus 2 over 3, right? Now, critical number really means the number for which f of x is f dash x or f prime x is 0 or undefined, right? So, for critical number, f prime x should be equal to 0 or undefined. So that gives us the critical number. So let's find when is it 0 or undefined. Okay, so let's analyze it further. So what we have here is we have 1 minus 1 over x to the power of 2 over 3, right? So that is how we could write. 3 and 3 cancel out, so that is what we get. You could actually at this stage also take a common denominator. There are a couple of ways to solve this. So you get x to the power of 2 over 3. Here you get x to the power of 2 over 3 minus 1. Now let us figure out what critical numbers are for this equation. Now f prime x equals to 0 will give us a couple of values, two values, right? So that means x to the power of 2 over 3 minus 1 equals to 0, and that really means that x is equals to plus minus 1. So for both the values this expression is 0, right? So that is one. And second, we need to find when it is undefined, right? So it is undefined at when the denominator is 0. That means x to the power of 2 over 3 equals to 0, and that is x equals to 0. So we get three critical numbers. So we can say critical numbers are at minus 1, 0 and plus 1. So that is how we get critical numbers. Now to find maximum or minimum, local maximum minimum, what should we do? Well, let us analyze critical numbers, right? So we'll analyze critical numbers. When I say analyze critical numbers, strictly speaking, I'm trying to analyze intervals which we get because of these critical numbers, right? So the critical numbers for us are minus 1, 0 and 1. So let us take test points, right? So we have this interval which is from minus infinity to minus 1. So we'll take test point. So test point for this could be, let us say minus 2. Somewhere here minus half. And here we could take half and then 2. So these are our test points, right? So we got test points. Now what we need to do is we need to find whether the derivative f prime x is positive or negative in these intervals, right? So what you observe here is that is the derivative, right? So that is the derivative we're trying to analyze. Denominator is always positive. This is always positive, right? Square, right? So when you square anything, it becomes positive, right? So denominator is positive. Now if I write x as minus 2, that means x is more than 1, then this value is going to be more than 1. So we get positive here. So you could calculate, so you get positive here. So that means positive means derivative positive means function will be increasing, right? So we say derivative is, I should actually say, not sketch it like this. I will write f prime x is positive. Let me write positive here, right? In this interval. Now if I substitute minus half, well, becomes less than 1, and therefore I'm expecting a negative value in this interval, negative here also, and if I substitute 2, I get positive value. You can enter these values in your calculator and also find the answer, correct? Now, if I say that f prime x is positive, then the function is increasing, right? So in this interval from minus infinity to minus 1, it is increasing. Negative means decreasing. So from minus 1 to 0, so that interval is from minus 1 to 0, it is decreasing. And then from 0 to 1, from 0 to 1 also, it is again decreasing, right? However, from 1 to infinity, it is increasing, correct? And we saw that from minus infinity to minus 1, it was increasing. So looking into that pattern, we can say we have local maximum at x equals to 1, correct? And we don't have maximum minimum here since both are decreasing, but we have local minimum at x equals to 1, right? So we can write down our answer that local or relative maximum, let's say local maximum, will be at x equals to minus 1, at x equals to minus 1, and local minimum will be at x equals to plus 1, correct? Plus 1. So to find the value, what you can do is you can substitute 1 here, right? So if you substitute 1 or minus 1 here, you'll get both the answers. So if I write minus 1 here, then the cube root will be negative 1. So minus 1, so the value of y will be, so plug in minus 1 here. So we have f of minus 1 equals to minus 1 minus 3 times minus 1 to the power of 1 over 3, which is negative. That makes this as positive, so you get positive 2. So the y value is 2. The maximum value is plus 2 for you, right? If you write plus 1 here, so f of plus 1 will be 1 minus 3, right? So which is minus 2. So this value is y equals to minus 2. So these are your maximum minimum values, local maximum minimum values, which happens to be at the critical number minus 1 and 1, right? So that is how you could actually solve this question, correct? So what we found here is that we have 3 critical numbers. The critical numbers for us are, these are the 3 critical numbers, minus 1, 0, and 1. And then local maximum, local minimum is at the point, you can write this point as local maximum is, so we can write our answer also here as local maximum is at minus 1, 2, and local minimum is at 1 minus 2, correct? So that is the answer for us. I hope that helps. Thank you, and all the best.